Welcome students, here I am Dr. Amjad Ali. In this video we will learn an interesting topic, that is lagged variable and differenced variable. Dear student, some of the importance of the lagged variable and difference variable has been discussed in autocorrelation session, but here we discuss the detail of the lagged and difference variable, why we take the lagged variable and what are the problems associated with lagged variable. Okay, the concept of lagged value or variable, the lagged value of a variable, which may be we have a dependent variable lag, we have an independent variable lag, and somehow we take the lag of our error term, is simply the value that the variable took during a previous period. Like, for example, the value of yt lagged one period written as yt minus 1 and can be constructed by shifting all of the observation forward one period in a spreadsheet. Like if we want to take the lag of x, so we can write it x t minus 1, like ut minus 1. So this is one period lag. Okay, here we have an empirical example that we have the year from 2001 to 2012. 12 year data are available. We have any variable, that let's say we have a yt, a variable, and the value of yt started from 2001 to 2012. We are here first interested in one period lag. So when we are taking the one period lag, then our data of 2001 will be started from 2002. Started from 2002, which is actually the value of 2001. And now we have 11 observation for empirical analysis, and we cannot put any value in front of 2001 year. This is our empty year. And if we are interested in two lag period, so see, we put nothing in front of 2001 and 2002, but 2001 value now started in front of 2003, and now we have 10 observation for the empirical analysis. So this means that higher the number of observation, lower the number of values or observation for the empirical analysis. So like that we can take the 3 period lag, 4 period lag. It depends upon the nature of the data, available number of observation, as well as theoretical modeling or theoretical link for taking how much lag you are taking. Okay, now we are talking about the difference. When we are talking about the difference simply the difference mean you have to subtract next value from your previous. So see, we have taken the first year lag. Now we subtract 31 minus 34, 55 minus 31. So every next value we subtract previous value. Every next value minus previous value, and we get a series, and this is known as first difference series. Now we can use it for our regression analysis. Okay, if we are interested in second difference, now we subtract the two lagged period values, and here we also put nothing in front of our first 2 years. So we subtract 31 minus 31 no sorry we have to subtract 24 minus 13 minus plus minus 34 minus 24, 50 minus 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 plus 34. So this is our second difference. So keep in mind, when you are giving the interpretation, you can say that this is 1 period lag, 2 period lag, or 3 period lag. And when you are talking about the difference, it is called first difference, second difference, or third difference. And when we are talking about the difference point of view or lagged value, so this is called our level. This is called the level value. Current year value is normally known as level period. Okay, why might lag be required in a regression analysis? As I told you that there are number of variables which there are number of explanatory variables which cannot affect immediately on our dependent variable. They need some time to affect the dependent variable. So that's why somehow we take lagged value. Okay, lag value of explanatory variables or of a dependent variable may capture important dynamic structure in the dependent variable that might cause a number of factors. So moreover, so keep in mind that when we are taking the lagged value or difference value, so normally this is known as the dynamic structure. And when we are not using any type of lagged or difference value in our model, so this is normally interpreted as static model. Okay, two possibilities that are relevant in finance and economics as follows. The first one is inertia of the dependent variable. Second one is the overreactions. Okay, let's discuss the inertia of the dependent variable. Okay, often a change in the value of one of the explanatory variable will not affect the dependent variable immediately during one period, but rather a lag over several time periods. So that's why I am explaining you that there are a number of events which cannot affect financial variable, economic variable immediately. They need some time to show their effect. For example, the effect of change in market microstructure or government policy may take a few months or longer to work through, since agents may be initially unsure of what the implication for asset pricing and so on. Okay, more generally, many variables in economics and finance will change only slowly. There are a number of variables which change slowly in economics and finance. When we are talking about the education, when we are talking about our financial system, so they take some time to change. Okay, under such situation, dynamic structure, as I told you, the static and dynamic structure. So dynamic structure, lag value or difference value is the best for the empirical analysis. Overreaction. Sometimes financial market overreact to a good and a bad news. For example, if a firm make a profit warning implying that its profits are likely to be down when formally reported later in the year, the markets might be anticipated to perceive this as implying that the value of the firm is less than was previously thought, and hence that the price of its share will fall. So sometime overreaction will also need the lagged or difference or dynamic structure for understanding the true value of the shares in the market. Okay, if there is an overreaction, the price will initially fall below that which is appropriate for the firm given this bad news, before subsequently bouncing back up to a new level. Under such situation, dynamic structure or lagged value or difference value is likely to be the best for the empirical analysis. There are some problems which are associated with the lagged values. So problem with adding lagged regressor, in many instances, a move from a static model to a dynamic model will also result a removal of the residual autocorrelation. You can say that the error term autocorrelation or serial correlation. So that's why we prefer lagged value. But when you use the lagged value for your regression model, there are some additional issues or additional problems, although you have removed the autocorrelation of your residual. First one, inclusion of lag value of the dependent variable violate the assumption that the explanatory variables are non-stochastic. And second one, what does an equation with a large number of lag actually mean? The last one is loss of degree of freedom. Okay, let's discuss the detail of inclusion of lag values of the dependent variable violate the assumption that explanatory variables are non-stochastic. As we know that y is determined partially by the error term, because most of the variation in the dependent variable is explained by our independent variable or explanatory variable. So remaining part of the variation is explained by our error term, random error term, and we are suppose that our dependent variable is stochastic and our independent variable are non-stochastic, random or fixed. And when we use the lag dependent variable as an explanatory variable, so we already suppose that following the assumptions of OLS, yt, our dependent variable is stochastic, is non-random, but our independent variable is non-stochastic and random or fixed in repeated sample. So when we use the lag dependent variable as an explanatory variable, so this will violate the assumption of OLS of non-stochastic. Okay, in small samples, inclusion of lags of dependent variable can lead to a bias coefficient estimates, although they are still consistent and implying that the bias will appear symptotically, like when we increase the sample size, then this issue will be resolved and our parameters are consistent and our parameters are no more biased. They become unbiased when we increase the sample size, but this is a later case. But as we take the lag, then our parameter will become biased. Okay, what does an equation with a large number of lag actually mean? A model with many lags may have solve a statistical problem, like we are interested in removing the autocorrelation of the residual or autocorrelation of the error term at the expense of creating an interpretational point of view, like the empirical model containing many lags or difference term is difficult to interpret and may not test the original financial theory that motivated the use of regression analysis in first place. So that's a good sign. We have no autocorrelation issue in our error term, but with increasing the number of lag, we cannot give the good policy suggestions to our businesses, to our financial you can say that the financial advisors. Okay, loss of degree of freedom. What you mean by degree of freedom? When you are talking about the degree of freedom, it is n minus k. So degree of freedom explain what? See here, the number of degree of freedom explains the actual number of variables are available in final calculations. So see, normally degree of freedom is written as n minus k. So n minus k mean n number of total observation, and k mean total number of parameters. So when we n minus k, then this will show that how much number of observations are remain for our empirical analysis. Let's see, here we have a data from 2001 to 2012, YT is our variable. So if we see here, we have n minus k, number of observation is 12. Like we are using the first year lag value. Now we have, see here we have, if we are interested, then we are taking it as a independent variable. So now see here we have 11 observation for the empirical analysis, and as much as we are increasing, then the loss of degree of freedom will be occur. So if we have a 3 lagged period, then we have only 9 observation for the empirical analysis. So keep it in mind that as much lags we include, our degree of freedom will be reduced, because we have to include a independent variable as well as constant for the interpretation point of view, or parameter point of view. So this is all about our lagged value and differenced value. I hope you got it well. Thank you. Okay, see you with another video. Ciao.